Hello everyone, I, Ria Pahuja from ETCIO, welcome you all to yet another webinar enabling future-ready AI cloud operations. Computing needs for applications are evolving at breathtaking pace. Digitization of applications has accorded even more importance to it because new age applications demand even more flexibility and resilience from the underlying infrastructure. Today, this webinar will touch the future of cloud computing, including concepts like containers, serverless computing, and the use of artificial intelligence in running infrastructure operations. For this very topical discussion, we have with us Santosh Akkula. He heads the cloud services at Bharti Airtel. Welcome you, sir.
Thank you, Ria.
Being a
Good
technology leader,
afternoon,
he
everyone.
has more than 20 years of experience in infrastructure projects across multiple technologies. Before we begin this webinar, I request all the attendees to please drop in the questions in the panel provided. We will take the handpicked questions at the end of the webinar. Mr. Akula, I request you to please take this forward.
Thank you, Ria. Thank you for the introduction. Good afternoon, everyone. So we are currently talking about how cloud operations are being enabled with AI. That's the fundamental premise of this presentation, right? So how we have enabled AI ops within Airtel's infrastructure and how we have been helping ourselves in improving our user experience overall, right? So if you look at September 2016, which is 4 years back, we had some phenomenal challenges in terms of the way we used to serve our business applications or our customers, end customers, the way they operated. So few challenges which we have listed: 30 plus disparate tools, 80% of infrastructure was legacy. We were tied to a single OEM. Our infrastructure was monolithic in nature. We had no visibility or very limited visibility in terms of what was the data path flow out, what was the how service was flowing, and how do we fix. Had about 100,000 high volume knock tickets at any point in time, which we were looking for a needle in a haystack to find out what exactly was causing the issue. The average resolution times for our incidents were about 210 minutes. And one of the fundamental failures we were seeing is that the time it took to raise from the point the event gets generated and it gets ticketed was about 10 minutes. Amidst of all these things, we were running about 50 plus incidents every month. These incidents were high severity in nature, which basically means that our applications were inaccessible and our customers were basically not able to do business operations. And we were a completely human-oriented operations. If you look at these challenges, these are the typical IT operations challenges we see on a daily basis, right? Most of us end up looking at problems and saying, you know what, yeah, 50 outages, how do I bring it to 40, 30, 20, right? And how do we reduce the number of the minutes it takes? But what we realized over a period of time is that the number of outages had a direct correlation with user experience. And every time we were having an incident, we were losing credibility in the market, we were losing customer base, and we were using a revenue loss because the applications were not available. Being a telco, our recharges would not happen. A lot of things kept on happening and the business was not very happy. Then we had to change something which will ensure the customer facing applications was always available. The other scenario was our CRM systems would be down and we are not able to serve customers, and that was a huge disappointment in the overall business. So we decided to change something. Then we started with small steps of understanding how do we remediate. So today what happens, right? Fast forward 2020, these are data points segregated to December 2019. 84% of our incidents are auto-healed. What basically means is from the time the event is triggered in the system till the time it is auto-fixed. Everything is done humanless. So a bot would kick in at the right time, make necessary changes, either do a change management to fix the issue or do configuration changes. Everything, 84% of our events are completely auto-healed. As I was describing in the previous slide, we had 50 plus outages, right? Uh, Currently, there is a 94% drop in the severity rate. What basically number drives is that less number of times we would have our customers who are trying to recharge or trying to do some transaction on Airtel or trying to do a transfer on our payments bank. The probability of a user having a problem doing any of these digital transactions is very minuscule. Uh, we- by automation, we have achieved one significant thing is that we've realized our time to respond has dropped by 95%. What used to be 210 minutes on an average to resolve has significantly dropped. We have seen a 95% dip. The other advantage we have seen is we had resources sitting just doing eyeball monitoring on a daily basis. So we have reduced 85% of our resources in NOC, and the resources that are reliant have been repurposed several other duties, and there are a lot of people in automation doing the same job. So how did we, one of the biggest questions that comes out is, how did we do this, right? It was not an easy task. We've realized that uh, as the processes needs to be improved, the technology and the adaptation of our way we look at our technology and processes had to change and had to continuously evolve the way we operate in our daily business. So these are the few things we did. What did we do? We focused on few areas, right? These are very simple building blocks of AI and ops. These are pretty standard things we did, right? First thing is we moved from a fundamental fact of saying, from a systems KPI, how do we become business focused? So if instead of anyone coming back and saying, oh, my systems are down, we said, how do we proactively detect the events which are causing business impact, and we notify the business users ahead of time, right? The second most important thing is, in order to do that, the most important thing we played is, how do we change from a system KPI to business KPI? Most of the times, the end user says, or our business users say, oh, my application is slow. It could be several components to it, right? A disk latency might be going, a network throttle is happening, a VM is not performing to its capability, a database is not working, right? One of the biggest challenges, if you look at these isolated situations, uh, 20 people could be working, but we said, if we want to become business focused, we only track the availability of the application, and the rest is the residual part of it. So we had to put some fundamental building blocks of algorithms understanding, collecting the data. We will talk a little more in the detection mechanism, how we did it. The second thing, and the most important thing, was agile operations, right? Typically, agile in cloud operations is scaling up VMs. Yes, that's one way to do it. The second agility we have looked at is that, how do you dynamically correlate events in the ecosystem so that at a given point, if a disk latency goes up at that moment, right? Uh, the business users does not look at the disk latency going up. He says application not run. We're saying, how do you do a real-time analysis and be agile to understand what is causing the problem, how we do it, right? The third part was secure, right? When any transaction happens over the internet pipes, we needed to ensure that the data in motion and data in rest had to be secure. So we did a tremendous amount of automation in terms of our security as well. And then we looked at, we started building a huge correlation engine, which helped us to become very intelligent. Instead of going and looking into multiple segments of data points, our systems are able to correlate everything today and come back with a very specific action which needs to be remediated, and a workflow comes in and kicks in. We will talk a little more on the intelligent operations and remediations in a while. And the most important of all this is customer centricity. Whatever we have done, we have ensured that our customer faces phenomenal experience Either it is a physical touch point, it is a digital touch point. He could be standing at a kiosk making changes. So anything that happens, we've ensured that all our fundamental KPIs are aligned either to business focus or customer focus, so that we became very, very effective. So these were few of the guiding principles of our NOC. We said we fundamentally changed from a systems KPI to business KPI. We said, let me give you a very classic example. Typically, we, as a systems administrator, an IT administrator, we would look at and say, oh, the system is up or down, or an application is available or not, right? We said that's a very traditional way of operating, and that does not give us the view we would need. We started measuring what is the success rate of an application serving the customers, right? If how quickly we are able to render Airtel.in web page to the users. If we are probably looking at a web page, what are the properties of the web page? How are we delivering the contents on the web page? Is the web application compatible with, is able to scale itself to a mobile, desktop, laptop, depending upon the configurations they have, right? So these were the business KPIs. And then we used to typically look at 20 people looking at 20 different products of tools and said, oh, this is working fine, that is not working fine. Then we said, from aggregation to correlation. Correlation helped us in two fundamental ways. The first one is to identify an outlier very quickly, and correlation also helped us to say, what kind of workflows and business decisions do we make so that our decisions are quicker and they are very accurate, right? With the typical knocks happen, we were a very human intensive. Everything was manual from the time events get showed up, alarms get showed up on the monitoring tools, creating tickets, and then understanding what happens, working through different groups. We said all this needs to get automated. So from manual to complete automation was one of the strategies, right? In the process side, we looked at and said, we cannot have system KPIs, but business KPIs and customer-centric KPIs are the most important pieces which we had to fix. By doing so, what we realized is just not the business KPIs increased, the customers' retentions also went up in multifold, right? We couldn't quantify the retention rates, but what we've seen is whenever someone comes and spends certain X amount of time on our websites, that time stayed a little longer. They did much more transactions over our websites. So multifold increase in terms of in business KPIs and user KPIs increased. So one of the humanless knock operations we wanted to say is that from an event to tickets, which is one of the most horrendous cases we had to see, where we had to take 10 minutes to even from the alarm to ticket transition was 10 minutes. Well, the first thing we did is to automate the whole process, that anything that happens on an alarm, go ahead and raise a ticket. So that was one of the fundamental focuses we did, which ensured that we had no human intervention when this happens, right? Then the second challenge we overcome was impact, right? When aggregation was going on, people used to manually look at the alerts, call out and say, this is happening or that is not happening. We said, that's not working. We said it's a fully correlated engine. So we built a grounds up correlation engine into every single data point we could get. One of the challenges we also faced during this process is data sanity, right? So the data points or the alerts were in multiple formats. We had to bring all of them into a single standard format so that these can be correlated. I'll talk a little more on the correlation once we are doing. The second most important thing was when an event happens, it takes a lot of time getting people onto a call, making them understand what is going on. We completely ensured that instead of humans calling out, whenever an event gets kicked in, an incident gets kicked in, we went completely voice calling. So the bot looks at something, it finds out which business group which application group has to be called out, and it just seamlessly calls. Currently, we do about 80,000 calls a month. You can understand the scale at which the bot operates. What did it cost? All these things happen, two things. 72% of our incidents are resolved, and huge reduction in the mean time to resolve. So if an incident happens, we would make very quick changes, and then the resolution happens on the fly. So I will dig a little deep in terms of process, right? So the process is broken into three different strategies, right? One of them was detection, remediation, prevention, right? If you look at detection, why it is becoming complex, right? Now the hardware and software systems have become more efficient, right? If you go 10 years back, systems were monolithic in nature. Hardware failures were the predominant thing. Most of the things you would say, NIC card failing, motherboards failing, hard drives failing, systems going down abruptly. That was the thing of the past. Now systems have become capable, right? They have been smart. The failure rates are sub 0.2% across the industry, but they're becoming more and more complex. Let me give you a very simple example. From a monolithic environment, OS was the only dependency. Now, virtualization has become one more layer of complexity into the process, right? Over provisioning has become one standard way of operating cloud. So hypervisors enable you to do CPU over provisioning and memory over provisioning, right? That adds to huge complexity, right? IT teams have to plan, manage those resources on the fly. And now if you look at in the recent 2 years, we are seeing a lot of trend over microservices, containers, and the number of API calls that are happening over the infrastructure is phenomenal, right? There are infrastructures which are calling about 200,000 APIs at any given moment. So the complexity is growing for the IT guys, while the application guys are given full control over the infrastructure, but making it available and application availability is still with the IT operations guys. So orchestrating all these things have become a huge challenge. Detection has been one of the key things AOps should focus, and every IT person needs to focus, right? If you look at detection process, there are two ways to do detection. You say disk utilization going up, straight cause and effect action. Disk utilization going up, certain processes come in and kick in. But what happens is no one says your disk utilization is going up or your memory utilization is going up. What people talk about is I have an application performance issue, right? Once you start doing that, you have to look at, let's say Airtel.in is not working at this moment, there's a performance issue. There is a web tier over it, there is switches served from two different locations, about 700, 800 servers serving the data, multiple VMs looking into it, storage, multiple disks in it, OS clusters, so many things are happening. Now it's not a straight cause and effect. How do you look at it? How do you detect the whole equation so that it becomes easily dissectable, and how can you make things work very quickly and very effectively? If you look at in this path, you would have at least 7, 8 different groups working together and saying what has caused the problem. It's just an open-ended statement, performance has an issue. What do you do after performance is 10 people running around and saying, okay, this, and idealistically experience says that it takes about 25-30 minutes for someone to say where the problem exists. And in my experience, I've seen it takes a couple of hours before we can say there has been an issue, right? Here is where we can nail the problem. So we did this, right? We said, what do we do? So we took every component into the network in the systems, server, network, database, storage, and put them all onto a huge Hadoop data lake and started correlating the events together. So 4 possibilities in this, right? Collect all the data from OS storage data, put it there, and find out what algorithms which make sense for you at that point in time. I'll go back to my disk latency issue example. where there could be a disk latency on a storage drive, but it says it could degrade. You would not know what happens. Disk latency will increase the IOPS condition on the storage, then it creates an impact on OS, then the DB performance, all these things would start. For someone to understand disk was the issue, you need to do a top-down approach and say web tiers, app tiers, databases, OS, and then comes last the disk. It, in all probability, the disk latency might not even be get recorded. Right? We put a huge correlation engine with absolute level of algorithms to understand what happens real time, and it looks at business KPIs and business metrics and says what are my transactional analytics, and understand the context and flow of events. So across the distributed systems in one single pane to understand these are the challenges I'm having, these are the two potential problems, and boom, we would go and make those changes uh, in a fly with our bot systems. So this technically bought us a 75% reduction of MTTR over the incidents. So it typically takes anywhere between a couple of minutes to few minutes to ensure that we nail down our problems and identify the exact root cause and kick in a workflow. That is how the fundamental change in detection happened. If you look at detection itself is the most critical piece we have noticed in our whole strategy. Detection combined with source of data from where the source of data flows in, right? Data cannot just come from monitoring things. There are several ways to look at data. And once the data comes in, the source of data needs to be sanitized. Data needs to be normalized, and data needs to be articulated in a fashion that the system understands and comprehends and makes the right decisions so that the right bots can kick in and the workflows can be executed. So this is one example where we look at what happens across all my data center sites, right? And it gives a very categorical example. Someone sits in the branch office or a data center and says, oh, my network latency is bad, right? And it is impossible to find out why, right? Unless otherwise there is a context to what we are trying to do. So we built very specific dashboards and saying, what is a typical expected latency from a data center or a branch office to my actual data center? And we said, these are my benchmarks. It looks at a 200-day moving average and said, in the last 200 days, this has been the median latency, and this is what is happening. So depending upon the latency terms, we would define which color, and we would say, we give it to the users and say, this is the problem, and our bots would go automatically make changes to the systems and then bring it to normalization. We'll talk about the next example. This is our network analytics. Right? We look at 7-day trending in our network switches. Uh, uh, so we were not able to. We were looking at data points at that moment, and we never ensured that we looked at what historical patterns were. So let's say my business transactions being very standard, what would be my network latency? Or once the network latency breaches, we'll say, what is my business KPI variation? So if you look at the example that's highlighted here, right, the variation from D1, D7 to D1, which is D now, we used to have 178 transactions for this example, and on D7, and today it is 14. So the variance is about 92%. We built in a threshold right into it that if the threshold reaches 30%, then raise an alert. If 30% is, if it is below 30%, it's business expected that there could be a 30% deviation in the business, in the KPI metrics. So we said eliminate those. In this case, there's a 92% variance, which is much beyond 30% we declined. The system automatically throws up an alert into the business user group saying that there's a problem detected, we are working on it. And in no time, the system will also come back and say, system has been fixed, everything is back to normal. So this is one of the classic cases we have seen where we've been able to reduce the time it takes to resolve and to identify. And the most important benefit we have seen, as I always emphasized, is benefit to the customer and benefit to the business. This has been paramount for us, right? Uh, Prediction has always helped us in a big way. If we have not been able to predict the behavior of the system with thresholds, this could have been possible. So we say prediction models have to be perfect, and the remediation is the next big thing. So one of the things when you are embarking the AIOps journey is that if you are able to do it because you are able to analyze the data faster and at a higher speed. Getting the right data is the key to this business, and getting the right correlation engines in place is the next big thing. Now we will touch upon a little on the remediation part, right? While we understand detection is one of the key things, what do you do with detection, right? You detect, what do you do next, right? You either put people on for detecting, remediating the detections, or you put an automation tool or any of these things. We decided, so once we were very thorough with our detection mechanism, we said remediation needs to be focused. Once remediation needs to be kicked in, uh, this is what we did. We had to first understand what are our typical trigger points, right? If it's an incident, it's an alert, it's a change. These are the fundamental parameters in any business. In our case, ServiceNow is our ticketing tool. Everything gets fed into it, right? Now, once it comes into ServiceNow, what do we do it, right? The ticketing tool takes all the events and puts into our decision tree tool, which basically does a real-time correlation and looks at audit logs. It looks at every kind of a log that's available, does 3 level of inspection and says which algorithm I need to put in, right? And it says, do I need to kick in a workflow? Should I make in a CI/CD change? Do I need to kick in? Do I need to call an API into either VMware F5 or Windows Active Directory? Or should I log into a Unix machine and fire a command or do a bash process? So we looked at everything and said, these are the fundamental building blocks. When a decision is made, what action needs to come in? So the intelligence layer had two very fundamental components. One was correlation, and the second thing is on this correlation, what kind of algorithms we do pick, right? Algorithms were very, very critical. The algorithms run into multiples because for a single event, you could have multiple choices to pick. Which one should be applied first and which should be applied second? In a similar case, in two different contexts, the same algorithm will not work. So we had to go back and refine our algorithmic processes even more detailed to affect so that our mean time to resolutions come down. It took us literally over 3.5, 4 years to reach the point where we have been, right? Uh, it's like situation and action. It looks at every single parameter within the infrastructure, and it has every single decision making capability. Either it has to kick in a change on the code, whereas Jenkins, if it's an infrastructure, let's say a VM is not performing it to the capability and it says VM resources are not sufficient, it kicks in a bot and says, do I need to kick in an accessible workflow, or should I go into the hypervisor and say, should I create a new VM or increase resources? If there is an increase in traffic and the CPU utilization of a VM, it's hitting 90%, it makes the right decision and goes and creates a new VM and automatically creates a rule in F5 load balancer so that both the VMs come into effect and ensure that the workload gets split on both the VMs, right? One of the other most important things we have noticed during this process is that no matter how much of infrastructure automation do you do, if you do not do security operations, it has no meaning. Let me give you an example. In one of the basic slides I spoke about security, right? We've realized that while you do a lot of things, there are so many external parameters which come into play. One of the fundamental factors, you might get impacted with a DDoS attack at any moment. Typical DDoS attacks take considerable time for you to remediate, to identify the source. About 20 people running around, you're not looking at it. We said, we will not do a manual run around business. We will take immediate actions. So the first thing we did is we looked at every single parameter that's connected into a network. All our firewalls, load balancers, networks, user logs, application data, end user devices, and said, we would detect everything. We would do a real-time assessment of the situation and create an action using ticket and respond to it. So let me give you a very basic example of DDoS. If we assume that from one's destination, source IP, we are getting flooding, which is a volumetric attack. The system detects a volumetric attack uh, and immediately calls in and uh, finds out which aggressive scan it has to pick. It goes and scans the network, uh, finds out the firewall on which this needs to be blocked. It just goes and puts a policy and says we do the policy is implemented and DDoS is remediated, and then it constantly keeps observing over a certain period if there are any volumetric attacks that are happening. You could take multiple examples. If you look at today's scenario for us, 73% of our firewall cases are completely automated. 8% of our VPN cases are completely automated, right? And 6% are end user cases. If you look at the whole gamut, we've ensured that most of our security events are completely automated so that human intervention is very limited. Humans are only to do post-fact analysis to find out how do we make it more secure on a regular basis so that our systems remain stable and our user experience is maintained at the highest level. So today, 73% of our all tickets are completely automated in SAARC, and we aim to be 100% automated by March 2020. So our journey with all the things happening, this is what we have achieved. We have reduced the number of resources needed uh, to a significant lower levels. Just not lower in terms of people, but in terms of efficiency, there has been a high value benefit where our business is seeing, which increases revenue. It also increases customer retention. Uh, that helps us in multifold. Then we come to the prevention piece of the process. That's the three-step process we spoke about. Oh, sorry. The prevention piece, when you have all the right parameters in your right data sets in your correlation engine, uh, once the anomalies are detected, if you are able to do a real-time analysis into your systems, the most easy piece of the whole process is creating prevention. Uh, while doing prevention, you also have to keep one thing in mind, and it has been our experience that it's not one solution fits all situations. You need to be able to articulate and understand what does individual events mean and incidents mean, and how are you going to ensure that those preventions are right for the business. This is not always going to be right. There are times you have to go back and course correct. In our case, we had to do multiple course correction for prevention. This 4 years journey has taught us a lot in terms of detection, remediation, prevention. Today, we focus very less on the incident, but we focus more on the continuous improvement on our AOps. The process itself has become so effective that we are able to ensure that from the time detection happens till the prevention, we are constantly making changes on the fly and every day a change kicks into the system to understand what happens. Uh, One cautious point you need to take is when you're collecting data, you need to absolutely be sure what kind of a data mining are you looking at and what are the cause and effect for the data set that comes in. In our experience, couple of data sets wouldn't have made any sense. We had to go back and make a lot of changes to the data sets that are getting in. We had to deploy some uh, deep OS level predictions to understand what happens. Right? Let me give you an example. Typically, all the times OS, typical OS situation is OS on go and reboot. Now, what happens after that? We would make uh, when you take a reboot in the haste, we are not able to identify the root cause and you'll never be able to prevent. We had to go and deploy some deep K probes into the OS to understand what it meant and what actions we have to take to ensure that these things made a lot of sense. If we had missed for the first time, we had to make decisions and information gathered much more deeper and get the right preventions in place. So everyone, that's where I conclude my presentation. This is our brief journey of what we have done. We have not been able to dig a lot of deep into technology pieces. We wanted to keep it very short and concise considering the time. Thank you very much. Ria, over to you.
Thank you, Santosh, for such an insightful presentation. While we start with our Q&A round, I still request all the attendees to please kindly drop in your questions in the provided panel. For the very first question we have, Mr. Santosh, how do you see the ecosystem evolving, especially in case of performance-intensive operations like Airtel?
So thanks for a great question. While we are doing tremendous amount of transactions, we had to keep three things into consistent thinking process. The first thing is we had to build robust infrastructures which are self-healing in nature, right? Performance comes with its own predicament. We had to build robust infrastructures. Second thing is we had to pick the right kind of platforms to ensure that we are always performing. Uh, we went from bare metals to VMs to containers. Now they are moving. Now we are moving into function as a service. With all these coming into picture, every single component needs to be evaluated with a certain third degree of eye and said what works, what does not work for the business. And the second most important thing we also looked at is said what business changes do we may need to make so that these things become more effective. So in sum, there is no simple answer for this, but multiple combinations which will make it more successful. So today we serve millions of transactions every day, and we do not, we ensure that the systems are available for customers to use. My recommendation to participants is that if you are running a scale application, we have seen Kubernetes to be one of the best way forwards for us. Helps auto heal very quickly. Decision making skills are right built into the product. So scalable applications have been very effective there. So that's the answer. Ria?
Sure, sir. Thank you. The next question we have is how important is data collection in AI operations strategy?
Very, very important. Yeah, thanks. That's another great question, right? Uh, we've seen, let me go back to a simple example, which I was talking a little while ago, right? Uh, Data, when you collect data, right, it becomes so imperative to understand what data to collect, right? Uh, Most of the pitfalls is that people look at what is given and in a canned way from the monitoring tools, look at them and say, oh, this is the data. But what we have seen is that data needs to be double clicked every single time. Don't look at a monitoring data. So disk latency. You just look at disk latency. It does not really make any sense at any point in time. You need to get data in the full service for path, what we call it, from the cable that connects the intercable between the switch and the router or anything to the end serving point. You should be able to collect data consistently from all the devices at the regular intervals, and also ensure that the data collected is in the most simple format. Right? If you look at two different systems, OS gives you logs in OS Watcher logs, right? These are different formats. Web servers give logs in a different format. Uh, SQL databases give you formats in different format. So while data is being collected, most of the times when they are not converted into the right format and brought into a correlation engine, it does not make sense. So one of the pitfalls I would strongly recommend is to look at the right data sets. Always double click on the data set that is provided from day one. Go a little deep so that you will find even more meaningful data, and have a consistent methodology to bring that into your Hadoop cluster or any cluster intelligence systems you build. And after that, analyze it with absolute level of certainty using the right algorithms. That's where the whole data will become meaningful. Else, if any of these things are broken, it really does not make sense to build any of these things. So get the right data, look at the right data, and action the right data. That's the way we should look at it.
Sure. The next question we have is, how do you compare the Indian industrial cloud migration to the developed world?
Uh, can you repeat the question?
Sure, I can. The question says, how do you compare the Indian industrial cloud migration to the developed world?
So if you look at the cloud adoption, right? I am rephrasing the question for the person who's asked this. Uh, the question is how much of cloud adoption that has happened in India versus the rest of the world, right? And how much of data migration is happening. If you look at the latest Gartner report, we are way behind the cloud adoption. Cloud adoption is growing at the fastest pace. Currently, the cloud market in India is currently valued about 2.1 to 2.3 billion dollars. By 2023, Gartner expects it to go to about 7.1 to 7.7 billion dollars. So we are much behind it. The next 3 to 4 years are going to be super critical, that the lot of applications are going towards cloud, and with that migration, with that momentum coming in, a lot of data migration is going to come in, right? That is going to pose a lot of challenges in terms of India has just been, whatever small market we are in, only test and dev instances have moved on to the cloud. The majority of the workloads of productions are yet to move on. So starting next year to next 2023 is a super critical time frame for Indian cloud business, that a lot of migrations are scheduled to happen. So you will expect the industry to go by $5 billion in 4 years. So imagine the kind of data migration that's going to happen. Right?
Sure. The next question we have coming up is, what should be the starting point for automation journey for the organizations? Do you think we should go directly for a big bang, or shall we make the pointed leaps?
So there is every company has to evaluate its stance very clearly. The first thing we recommend, right? At least I would recommend is, sorry, uh, look at the process, right? Focus on deep detection. That's the first step, right? It could be a simple disk latency, or it could be a performance issue. Understand, transition yourself from system KPIs to business KPIs, right? And that's the first step of it. Once you have detection process fixed in, you understand what kind of data points do you need to collect. Sometimes you might end up 70% of your time finding out the right data sets. So always focus on detection. That's the most important piece. And the second most important is, once data detection comes in, remediation, and then prevention. These are the three cycles. These are the only way to do it. Can you do a big bang approach? The answer is no. Please do not embrace a big bang change. It does not give you the results the way you want, because you wouldn't have spent understanding time, the data that needs to be spent. that's the biggest fundamental loophole we see, that everyone says we will buy a tool and it will do magically all the work. No. Systems rely upon data. First, identify the problems, define the data patterns, and then go into the rest of the process.
Sure, thank you for that. The next question we have is how AI can be implemented for SOPs.
So if you look at artificial intelligence works on two fundamental principles. It needs to have a cause and an effect, right? This is the standard cause and effect. Now, an anomaly is a cause. You identify, look at a data point, understand the root cause. That is your data machine learning that gives you. AI comes in terms of two fundamental forms. One is AI relies upon your relative engine and says, here is, if something happens, this is the workflow I need to pick. Now, AI's capability to understand which workflow it has to pick and which has to be applied at that point in time, it makes context right, and the mean time to resolution reduces. Let me give you a very simple example. For a simple solution, that could be 10 steps. AI's capability to understand which step to apply and which step to skip is the most intelligent piece of it. So AI and ML has been stitched together in a format that it learns and it applies quickly, so that it doesn't have to go to 10 steps. Maybe it will take 2 steps. So that's how AI has been implemented.
Sure. Mr. Akkula, one of our attendees inquires about the automation tools that you're using at Airtel, if you can shed some light there.
So we don't have one standard tool which we use. So we use a variety of ITPA tools, RPA tools. We use a lot of open source. Ansible is open source for us. Our machine learning engine is open source. Our Hadoop data lake is open source, right? So we don't look at it as a tool, but it is a combination of several products together which creates this platform. So we've not relied upon a single tool to make this. Our decision tree has been built in-house for us. We use the same thing for our service desk to make decisions, to answer queries. We use the same decision-making capabilities that are built in-house. So not a single tool, but we use multiple tools. I would say that at least 25 tools in action at any given point in time, making this work.
Sure. The next question we have is how do you deal with a new event which is out of the KPI that may cause severity?
So that's where we have still incidents, right? I would not say that we have attained the nirvana state of AI ops. I did very categorically mention during my presentations that it is a continuous journey. Every time an exception happens and it is not fixed, you would need to go back and say, what I did, how did I miss, what is the new data set that comes in. One of the things we have categorically kept in our target is we said we will never go to zero incidents. We will always continue to have incidents, but the number of incidents will be limited. So at any point in time, we are always spending time to identify what are the new alerts, new applications that are coming in. How do we do correlation, understand? We are always in search of data within our ecosystem. So every time that happens, we go back to the drawing board, we start the process, we detect, we understand, we remediate, and we prevent the whole cause.
Sure, sir. Keeping the timeline in view, if you can quickly brief about the security issues that rise in virtual computing.
Two things that happen is that when you if you don't have security in a virtual environment, data leakage is the most important thing that keeps in, right? If two VMs are working in the same VLAN and are of not two same tenants, data leakage is one of the biggest things we have seen, right? So data protection has to be built right into the VMs. And the second thing that we have seen is with so much of data exploding, there is a lot of DDoS attack that happens, right, into the ecosystem. There are a lot of trojans that get built in. So these things needs to be remediated, one from the perimeter side and one from the VM security, right? One of the things we do very effectively is that we use a lot of VMware infrastructure. So NSX is built right into the infrastructure so that we don't have, we believe we build the zero trust architecture with the NSX so that any data that is flowing for the specific service path is restricted within that service path. And the second thing is we ensure that the data when it comes is secured and there is no open vulnerabilities that are in the system which will exploit the hackers so that they can put trojans and put payloads onto the system. So multiple levels of security have been implemented. That's the way industry is moving, and that's how everyone should be looking at virtual virtualized environment security.
Sure. Mr. Akkula, we have one last question. If we can quickly take that.
Sure. Priya?
So the question says, did Airtel AI predict server's future SLA, vice versa, application log?
Can you repeat the question?
Sure, I can. The question says, did Airtel AI predict about server's future SLA, vice versa, application log?
Okay. So, this is the question I believe from my context is that how do you tie application performance to infrastructure performance, right? Uh, Look at it this way. It has very few cases it happens that you are able to pinpoint an infra issue. Infra issues are so limited at this moment. We look at application performance to be the pivotal of everything, right? If the application is not performing, if application is performing the way it is expected to perform and our business KPIs are being met, we really do not look at what is happening in the infrastructure because it's completely agile in nature, right? Let me give you a very classic example that happens in the infrastructure. We have hundreds of clusters running in the infrastructure, right? Serving one large application. The application performance is what we measure, right? And this application cluster is in excess of hundreds. It does about 200 to 300 API calls at any given point in time, being served from 6 different locations, subsets living in 10 different locations. Now, a simple fundamental philosophy is that the application which is front-ending the customer needs to be available. If one of the server goes down or something is happening, we have built redundancies in a format which ensure that the application continues to serve the infrastructure self-heals itself, right? Again, a classic case of AIOps. One physical node goes down, right? RPA comes in, kicks in and says, remove the host from the network, and it automatically goes and populates VMs in other places and other hosts. If not, it kills the complete VM cluster and recreates it on the fly with our tech that's up built in. So application is the front end. Business KPIs make every difference for us.
Sure. Thank you so much, sir, for coming up for this webinar. I'm equally grateful for all the attendees for being with us today. Stay connected for more such insightful sessions.
Thank you.